Hi everyone, this is Professor Lucien, and this is video 1 of 3 for week 9 for Occupational Safety Management, Safety 43/683. In this lecture, what I'd like to do is kind of just review some of the things we've covered in this course so far, particularly relating to injury data, and then introduce a concept called serious injury and fatalities, or SIFs. You've got 3 papers to read and review, including this particular lecture, as a foundation for the 2 steps we're doing this week for the Loss Run Data Analysis project, which is the identification and study of outliers and the trending and forecasting of our data to determine the performance of the safety program. All right, let's get to it. So as you recall, this is my continuous improvement model. It's very basic, but it's, again, what it's meant to be is a reference point that in order to educate, that's a good term, educate management on what's really going on the work floor, we got to get out there and talk with and observe the supervisors and workers to get their perspective on what they believe management expects, or how the strategic or organizational goals and rules apply to them. So it's the day-to-day things, and that's where safety occurs, right? Whereas up here, this is where safety is imagined. And so what's critical is gaining this knowledge, this information, so that these other things can actually reflect and actually become an influence for improvement. Another one is that safety is an attribute of work, which I think is something people forget, especially researchers, that they isolate safety as this thing that guides, but really it's in competition for other elements of work to get things done. Okay. How do we gain management commitment? Well, we have to speak to their language. And that's where I really like work comp data, because it provides a dollar value to the things that are going on. And when we're going to be asking for investment and support. And if we can put a dollar value or a return on investment in those recommendations, we're more likely to, once money has been put forward, there's probably more of an interest. But 2, we're contributing to the greater performance of the organization, which allows us to have greater reach or control or influence in the organization. If we're isolated as a person who is relegated to working under HR, and we're just going out and doing the compliance-based approach to safety, we're never going to be that successful. We're not going to have the influence needed. And so it all begins with our ability to persuade management or sell management. It really does. And that's why I'm teaching you this technique, because it allows them to understand you from their perspective. Yeah, I think that's the way to put it. Another thing I want to review is my work system model. People assume, is that the proper term? People behave based on what is given to them and the environment they're in. And there may be temporal or non-persistent influences, situational influences, personal conditions, that affect our ability to make decisions and behave at work. Again, the focus is to get the work done. How safety is integrated into that, or a consideration, is dependent on these other things, right? And so a person has no exposure, they don't get hurt. Person has an exposure but no injury, we ignore it. We only get involved when there's an exposure and an injury. And I want you to keep that in mind. There is a great advantage to getting out and understanding these things as well. And then when we identify sources of I don't want to say deviancy. I was going to say deviancy from the expectation, not deviancy in the person. But when we deviate from what is expected due to deviancy in the work system, we have to go back and figure out what's causing it. Because if we can control the things, control, fix, repair, or at least monitor, that's a better term, monitor fluctuations, variations in the work system itself, we can then we're in a better position to mitigate those things that influence the person's focus on something other than safety, or considering it in the work they do, to overcome situational, non-persistent, mental, psychological type barriers. Okay. What is continuous improvement all about? It's taking measures and tracking things. So looking at what data we got from the past, applying changes today, and then anticipating what things will look like tomorrow. And this isn't an actual 24-hour periods before and after, but rather, periods of time. But that's what continuous improvement is. It's driven by numbers. The root cause analysis approach is meant to better understand what is actually affecting it. And just to go back a couple, we should be using the root cause analysis to figure out this stuff. Okay, to not consider the person, but what is affecting the person. Organization, environment, task, technology. Those are simplified elements, but I think you're catching the gist. But what's great is root cause analysis methods, there are a lot of them. And so you pick the ones or the few that best fit the work you're doing. Let's go back to Heinrich, because as we talk about serious injury and fatalities, which I'm just going to call SIFs from here on out, they contend that it was an ignorant adoption or belief in Heinrich and Bird's pyramids that have led to the situation we're in now, that SIFs are a big problem and that the minor things are not. I contend differently, and that's what I want to talk about. So if you recall, I took we talked about this, I think, in week 3. So I took the pyramids and I pushed them on the side, and I got distributions. We did distributions last week, and they aren't too different from what we're seeing here, that there's a lot more non-severe or no severity than there are the major things. So these happen more often, but the question is, are we monitoring? Are those being reported? Are we monitoring them? Are we going out and doing some form of investigation of root cause? So, I'm sorry, I meant to go back. Root cause, so we can figure out because the contention is, if we just fix those things that go the minor, the major will never happen. That is not true. Okay, that there's some coverage there, but it's not always true. But if we're ignoring the data, then we're ignoring some things we need to know about the organization. And again, I'll go all the way back to this right here. Minor, near miss and stuff. The effort to investigate and have those things reported is a result of this effort. So if you want to, measure performance of the safety program, the more you involve workers, the better. So are we focusing on the wrong aspect of reports? That's been the big question that is shared by the SIFs people and myself. I believe, similar to Heinrich, that regardless of what the outcome is, whether harm or not, it needs some form of investigation to understand it. And then you code it so that it can be put into a tracking system. And that tracking system should prioritize certain efforts, certain corrective efforts, okay? Whether it's a common functional issue or unique to a particular task or time of day or piece of equipment. I do believe that OSHA standards focus too much on documentation and not identifying root causes and implementing change. I think that's very true. So the data that we're using is not full picture. It is a narrow view of things. Record keeping should be about understanding why and making changes, not just recording things. And I think that a lot of people get caught up in that. And then those are the people who are reporting data. And now we look at that data and we're thinking that it's providing some sort of predictability or better understanding, and it may not be. So, and also there's the whole idea that it's easier to blame the person and then nothing gets fixed. So I searched for a good definition of SIFs, and I decided let's start with the AI generated understanding of it. Basically, it has it's an exposure. They say incident, but I think it's an exposure that has the potential of a debilitating injury, which is life-altering, or death. It says it can occur in a variety of ways. Of course, they're trying to name them, but yeah, a fall from height is pretty serious. Being struck by a falling object or something that is moving fast, like a fork truck or something, that's very serious. That's going to do serious harm. Or coming into contact with something that's hazardous, whether it's an airborne or radiation, chemical, whatever it might be, can also be very bad. I would also put in there exposure to electricity. That kills too. Extreme heat, extreme cold, all those things, right? Why SIFs can occur include, okay, so failing to recognize a hazard. Sure, but you should be out there. You should really know what's going on in your environment. Even when new things come in, a mildly skilled safety professional should be able to assess that. And there's a lot of case study out there. Complacency or forgetting about the danger. Now, whose fault is that? So you didn't remove it, and you're making the worker make all the decisions to avoid it, yet you still want them to get the work done. So when they say complacency or forgetting, I see that as a weakness in the work system, that something more should have been done. Failure to identify and address human risk factors. Yeah, that's what I'm promoting by getting out and talking to workers and supervisors and then teaching management. That is HOP. And then high-risk situations, not identified or controlled. So rare things or things that maybe workers don't recognize as high risk, that is an issue. But again, whose fault is that? Things need to be identified. Sometimes we learn, but for the most part, none of this really should fall into the hands of the worker. So there's this paper. It was 2023, but in 2023, they're still trying to figure out how to define a SIF. And they came up with this life model to define it. But I like these two figures, and so that's why I included them. So it talks about inpatient, amputation, loss of eye, serious degree. So OSHA now publishes just these things. And so we may have some more in-depth to understand, and then maybe understand what led to it. Is it more of a common occurrence, or is it unique? And that'll become important here in a few moments. Amputation, fatality. And so there's a lot of different sources here that defined it. Resulting in lost time. No, I think that's too simplistic because the need for lost time is more or less predicated on treatment, what the doctor recommends, and whether the company has work, modified or restricted duty work, really. Hospital level injuries. So, I mean, some people just go just in case, and then all of a sudden it would count. So is it life ending? Is it life threatening? Is it life altering? I mean, they're trying to simplify it, I think, but yeah, there's still, it's still being debated. I question, did this all really start with Fred Manuel? Because he always had kind of a bug up his ass for Heinrich. I don't know why. But getting near the end of his career, most of his work was to criticize. And you guys did read a paper about him earlier in the semester. It must have been week 3, criticizing Heinrich's work. And so I took a few quotes here. And this is what Fred had said in 2004. Most incidents resulting in severe injury are unique. I don't agree with him. I don't. And this week we're going to identify outliers, pull them out and look at them. And I want you guys to think about this. Is it unique or is it everyday stuff? That's what you want to focus on. Not so much what was the severity or overall cause, but in the work they were doing. The problem is some of the documentation we keep doesn't go that far. And that's an issue right there. He also said typically safety initiatives that concentrate on the types of incidents that occur frequently do not address low probability, high consequence types of incidents. The word typically would mean a majority of time, and I don't agree with that either. I agree that, yeah, if you're going to be working at a height on an open edge, that's dangerous. There has to be some form of protection when you do that. If you're going to be working on systems that have high voltage, it's better to de-energize, but if you can't, there are other steps you can take. If you're going to be, working around heavy equipment or machinery, if it needs to be locked and blocked and checked for stored energy. If you're going to be going into a confined space, you need to assess it so that no hazardous atmosphere develops while you're in there. So there are things that we already should be doing that are maybe a little bit different than this, but he's saying typically, and I don't agree with that. Specially directed initiatives are necessary to identify and ameliorate the potential for occurrence of low probability. Yeah, I think there we agree, but I don't see how we're not doing that right now. There is a paper published by Cooper. I do like Cooper's earlier work. He's been ranting and raving on LinkedIn lately. I think it's a shame because he's done some good work, but he's very anti-hop. And I think the only reason for it is that I don't know if he feels that all of his previous publications would become null and void because of this new approach or what, but he's fighting against it like he's protecting something, and I don't get it. So what's interesting is Hale has done some great work specifically in offshore oil rigs, specifically to it says right there, safety culture. Major incidents can sometimes be predicted by minor incidents, but not always. There are always precursor signals, close calls, deviations of major incidents, and not all minor incidents could result in major incidents. I agree. Many SIFs, catastrophic or unique and singular events, having multiple and complex causal factors that may have organizational, technical, operational systems, or cultural origins. I agree. I think that there's a lot of clarity there in 2002 from Hale. Prompted by industrial disasters occurring on sites with very low personal injury rates, scholars such as Peterson, Hale, Manuel, and Krause, that's the behavioral safety technology guy, very much behavioral safety, question Heinrich's work. They highlighted the difficulties in making predictions about where the next SIF may come from, as organizations do not experience enough high-potential, low-frequency incidents to make meaningful conclusions. That's really trying to really read between the lines, I think, there. I agree. It's difficult to be able to predict where the next one will be, but there are things you can look at that it's like, wow, they're really not too keen on what they're attempting to control. So another part of the paper, according to Manuel, I just criticized his work, and Krause, who I'm not a big fan of, most potential SIFs are disproportionately related to unusual or abnormal precursor situations. Sure. I just talked about that. Working at height, working electricity, going in a confined space, having to climb into equipment that's not fully locked, tagged, de-energized, and blocked. The author defines abnormal as a situation not generally encountered during the course of normal operations. So you could use that definition as you review your outliers. A situation not generally encountered during the course of normal operations, okay? Though others may beg to differ. However, it is important to recognize everyday routine precursor situation also carries significant risks. Sure, yeah, it can. I mean, you can slip and fall on the back of your head and die. You can fall off a 10-foot ladder and it's a near miss. You just kind of get up, okay? There's a variety of outcomes. Routine precursor situation is defined as a situation which is repeated on a regular basis during the course of normal operations. Yeah. When analyzing 2 years of contractor data, the author, which is Cooper, found 90% of potential SIFs related to routine everyday situations. 90%. I like that. I think that I can agree with that. I can get on board with that. However, it was higher for abdominal event. I believe that too. This is more honest, I think. Higher proportion of routine SIFs precursors related to driving, maintenance, equipment use, and access egress. I agree with that as well. What are the primary causes of death? It's these. Experience shows every company will have its own unique SIFs precursor profile. I agree, which will reflect. Now, if they're just saying that when we do training, we should call out these things and call them SIFs because it makes them feel better, I'm fine with that. When I did new employee orientation, that's exactly what I did. I called out the things that are most frequent but less severe, and I also called out the things that are less frequent and more severe, and what we're doing to protect people from them. So I'm trying to educate the workers on that. So I think they could have gone a little bit further and talked about that. There was a paper published in Professional Safety Journal in 2001, and I know a lot of these people. I got to hang out with, what's her first name? In Denver, and we were waxing poetic on some work like this, and she is awesome. She had said something in one of the meetings, and I totally agreed with her, but I didn't speak up in the meeting. I don't do that. But yeah, so this is a good paper. I think this is assigned to you for this week. What do they have for takeaways for this paper? OSHA professionals not taking full advantage of safety data to help prevent. I don't agree with that, though. I don't. I mean, I agree that we're not taking full advantage, but the problem is I think we don't fully understand it. We have over-focused on accumulating common behavior and incident data that are rarely relevant to SIFs prevention. I don't agree with that. Grouping data according to controls as precursors. I kind of said that. That's what I did in my orientation, new employee orientation, and looking deeper at available data for both social technical systems. Yeah, social tech is good. Within a comprehensive safety management system, which I already talked about with you, can improve the identification of factors leading to catastrophic incidents. Well, I mean, again, there are certain things that are already catastrophic and they should be dealt with already. And you can possibly put in leading indicators like preventative maintenance and an error assessment on the operators. You know, are they able to respond to it? You could actually simulate that. Sure, great, but I think they're extrapolating a little too much. Are we focusing on collecting the wrong data? Now, this is one of my contentions. And what's really interesting is there's a tendency to underreport non-fatal injuries to improve that number. 100% agree. As a person who was analyzing the reports and management concerned about anything ever being recorded as an injury, yeah, there's a lot of motivation out there to have something not be OSHA recordable. Now, does that mean that we're suppressing information? Possibly. But you know, in my work, I was trying to get as much information as possible because I see value in it. And then they talk about recordability by the Michaels 2016. I had referred to that when we talked about Bureau of Labor Statistics that was done in Michigan. And here they're actually quoting Ron Gant. Later in the semester, you're going to hear a presentation with myself, Ron Gant, and Jeffrey Dalto. Gant just finished his PhD, I believe, at Ohio State. And now he's doing punk rock safety as a side gig podcast, and it's really good. He's doing it with a lot of the folks from Australia who are well ahead of us when it comes to safety differently, safety 2.0, and HOP. Though HOP is a Todd Coughlin product. They're the Safety 2.0 Eric Hallnagel, and Safety Differently is Sydney Decker. When it comes to identifying safe and unsafe behaviors, your employees are far more likely to identify obvious unsafe behaviors that lead to small accidents than to identify less obvious behaviors that are more of a gray area. Coincidentally, these less obvious unsafe behaviors are more associated with severe injuries and disasters. Yeah, Ron says a lot there. And he's gone out and done a lot of observations and applies a lot of social psychology to the work environment. And indeed, so workers will report, you know, we can train them to report concerns and things like that. But it's that effort to get management to understand the worker's perspective, more like its totality of the effort, puts us in a better position to put more resources towards those things that may be more severe. Okay, they're all intertwined. Nothing is separate. Everything kind of leans on each other, and that's where I think they're kind of some of this stuff they're missing the boat. They're not looking at the full picture. That's probably a good way to put it. Later in the paper, they talk about a central element of Heinrich's triangle metaphor is the so-called common cause hypothesis, and they actually refer to one of Heinrich's books. I think Bush has it, and I think it's so I think they're using the 1941. Now, I've got the book right here next to me. My version is, I thought it was, mine is the 1950 version. So it's the third edition. I believe the 41 was the second edition, and like 1929 or 30 or 31 is the original edition. So they go on and talk about, this central or common cause hypothesis. Looking at minor incidents more carefully allows organization to identify larger system weaknesses. I agree with that. That can serve as pointers to more serious issues and potential failures. So that's Todd Coughlin. He's the one who came up with Human Organizational Performance, or HOP. But what they're saying is that Heinrich is indicating that if we just fix the small things, the bigger things will be fixed. And that, therefore, is the need for the SIFs movement. Also, they quote Heinrich that for every mishap resulting in an injury, there are many other similar accidents that cause no injuries whatsoever. So Cooper had said that too. A key word is essential to understanding the common cause hypothesis, and applying the pyramid correctly is similar. So yeah, I was reading this. So I've got the book right in front of me right now, and page 24 is where the foundation for major injury, where the pyramid is presented. And I've highlighted a lot of this, such as when lost time or so-called major accidents only are selected for study as a basis for records and for guidance and prevention work, efforts are often misdirected. Valuable data is ignored, and statistical exposure is unnecessarily limited. I totally agree with that. And again, we're going to be looking at the outliers. Do we get a lot of insight from the most expensive claims or not? Is it better to look at everything in totality and possibly consider the more severe, more expensive claims as being unique? But we're gonna look at that this week. An injury is merely the result of an accident. The accident itself is controllable. The severity or cost of an injury that results when an accident occurs is difficult to control. Yeah, I agree with that. Sometimes the treatment takes longer. Maybe the treatment they initially select isn't the right one, and so they have to pivot to a new one. They usually try to treat the pain and hope the person recovers. And they may use something like functional splinting, or functional splinting, or a way to immobilize while it heals and deal with the pain. But if it's not healing, if there's something more severe beyond musculature or a strain, then they may have to go through therapy. And therapy varies in the ability to recover. Sometimes they go into injecting a serum that may speed healing and reduce pain. But if the person isn't healing based on what they believe would be the schedule for recovery, then they may refer to surgery. And then there's more time off and more expenses and more healing. And that's not always 100% either, especially since there probably needs to be some form of therapy and recovery. And if they're not following that properly, then that can delay the healing process. If they're brought back too early, it can cause a re-aggravation, which may be less likely to recover to 100%. And now you have a permanent partial disability. And then that is very severe. That's life-altering. Do you guys understand? The treatment itself, not so much the occurrence, would define it being a SIF and not the actual occurrence itself. And I think that's something that's really important to understand. Let's see, where else there was other things I was going to read to you. Much has been said of near accidents, meaning actual accidents that produce no injury whatever, although having the potentiality of doing so. That's an interesting word. These improper occurrences, these slips and fumbles, these near injury events, because of their proportionately greater volume, present to the capable person who is intelligent enough to take advantage of it a splendid opportunity to anticipate and prevent actual injuries. Yes, I agree. That's why you go around and talk to people and you gain their trust. And then they start reporting things like first aid, near miss, concerns that, I saw this concerned me. This almost hit me. And then you go out and you investigate. And maybe some of those corrections aren't going to prevent the big things, but the time and effort you put into developing those relationships with workers, opening up those communication lines, puts you at an advantage that you wouldn't be in if you had just waited for bad things to happen and investigate just the severe stuff. This was an article by Taproot just a little over a year and a half ago. And this is the general figure based on the Bureau of Labor Statistics, though it's a little bit older, some of them are a little bit newer, that shows that incidence rates are going down and fatality rates not going down as much. They provide some basic definitions here. Again, nobody is perfect, and I know Hallowell and his group are trying to do better at that. But again, the definition of being a serious injury or fatality can also be very much related to the treatment of it and not the actual occurrence. So, I've been doing some research with a graduate student, and we're still waiting to find out if the paper we wrote together is going to be published in the Bureau of Labor, the Board of Certified Safety Professionals Research Journal called SHIFT. If I don't hear soon, I may redirect it to Professional Safety Journal. But this is the BLS data from 2016 to 2022. However, unlike the previous slide, here they've got I think it's misrepresenting. So it's the fatalities per 100,000 and the incidence rates per 100. There's a problem there. The foundation in which it's based on is very different, yet they're putting it right next to each other. So what I did is I corrected that. I made it so that they were both based on 100 FTE, and look at the difference. Does it look like one's doing better than the other? I don't think so. I think both seem somewhat stagnant. Again, this is BLS, and I don't fully trust it, but I'm going to show you here why I don't trust it. All employee reports should be investigated. I agree. Anything. Go out and talk to the workers. It puts you in a better position to convince management what's really going on. Work being done versus work as imagined, which is that's something that Ron Gant always talks about. Heinrich and Bird advocate for volume of understanding and not just the root cause. Yes, I'm there. And you have to look beyond these things. Are some situations or causes more likely to result in SIFs? Yes, I already said that. I agree with that. But company data versus BLS OSHA, where it's skewed. It's very skewed. What does skew mean? Well, in order to perform parametric statistical analysis, you have to meet the assumption of normality, whether that's the population data or your collected subsample of data. Ideally, it's this normal curve, and you have similarity in mode, median, and mean. And you can calculate. These are descriptive statistics, you guys. This is what we can do. We can also get a standard deviation. The first standard deviation accounts for 68% of the population of the sample. 2 standard deviation is 95%. 3 standard deviation is 99.7%. With that basic, spread or distribution of the data and these general things, we're able to calculate parametric statistics because the form and consistencies tend to be there. When we have an asymmetrical distribution or something that's skewed like this, these 3 things are different. Now, when we do analysis, it means something else. Okay? And we got to be very careful about reporting and interpreting it. So if that assumption is violated, we need to be honest. If we attempt to calculate risk and the outliers will have a major influence, we need to compare outlier. We need to actually separate out the outliers from the more frequent data. Try to correct this a little bit. Identify what is skewing it, and if we remove them, does it improve it at all? What does non-normal distributions mean? I mean, very much you can look at the median and the average, or the mean, all right? Severe injuries are actually rare outcomes in unsafe. So yeah, so this goes with the SIF stuff. They're saying they're highly severe, or in work comp terms very expensive, versus the more frequent lower. But if we don't look at the data and understand the effect, then the numbers we're reporting are misrepresented. Over 2/3 of injuries come from overexertion, slip, trip, and fall, and struck by or caught in. Indeed, they do. They do. Why? Why is it continually there? Because we're not fully understanding it. And if we're just focusing on the things that cause this stuff, then we really aren't expecting it, or we're not studying safety from the perspective of work. We're studying from the perspective of just the hazards. So, unfortunately, this is trial and error. So I analyzed a data set years ago. It was an OSHA data initiative. And what I was able to do was compare distributions from 2002 to 2010. This is total case incidence rate. Down here is the DART. And what you see here is that the percent of no injuries reported went up substantially, about 3 times higher. The median went down, the average went down. So what this means is, and these were calculated individually and not overall. So BLS reports overall, this was individual entries. It shows massive improvements. More companies have 0 injuries reported, though, sure, they may be lying. But more importantly, there's a definite decrease, and that's in total case. We look at the DART, which is more of the severe number. We go from about 15% to 40% had 0 lost time injuries, severe injuries. So that went up substantially. The median went down to 2. The average went down from 6.5 to 3.75. According to the OSHA data initiative, companies are getting safer. Okay? Then let's compare some of my older work comp distributions. You guys, I do this every semester for over the last 14, 15 years. The distribution always looks like this. There's always, these ones on the end that are greater than 50,000. There's a few randoms in there. And we got to figure out where that cutoff point is. And then we look at the more expensive claims. And then as we move forward, we do the analysis with and without just to see if there's any subtlety or any differences. The idea being is we don't want the expensive claims to falsely inflate a priority. We want to be honest about it. So then just this year, every year, most companies have to upload their OSHA 300A data to OSHA. It's called the OSHA ITA, information something. And so grad student and I, we downloaded the data from 2016, actually to 2023, but BLS has only come out with 2022 so far, so we're just going to talk about that. And we did a descriptive statistics analysis right away. And as you can see in 2019, major issue. These should be somewhat consistent. They shouldn't vary too much. And this is calculated overall. We have a big dip here. It's really weird. And so where in 2019 did things go awry? And, okay, so we've got more entries every year, The number of employees, is that down? I believe that's down considerably. That's really a lot lower. And then, let's see, 1, 2, 3, 4, 5, 6, 7. Yeah, by a factor of 10. And then, the number of hours worked is up a lot. It jumped from exponent 10 to exponent 13. That's 1,000 times, ladies and gentlemen. That's 3 zeros. Do I have the number of average hours worked here? Maybe not, because this is the original and I got averages. So that's what caused it. When I did the calculation later on, what this basically meant is there was a few companies who over-reported hours worked. In fact, one company reported that each worker put in 2.4 trillion hours that year. That's impossible. That's absolutely impossible. It was an entry error. And so what we did is we found that we needed to remove some erroneous entries and then remove ones that were outliers, both high and low on the scale. And after we got all done, we had an average removal of about almost 13% of entries, which represented 76.5% of the number of employees reported. So there was some over-reporting there. Yeah. Hours worked, we reduced it by 46.7%. So there's issues with hours worked as well. The percent of 0 cases, we removed 17% of them. So there were some errors there as well. But here's what's interesting. The actual reporting of incidents only went down about 1.5 to 2.5%. What does that mean? It means the biggest errors in this system Are people, properly reporting hours worked and number of employees they had? That's the biggest issue. By far, that wasn't as big an issue. I think that's really interesting. Kind of goes against what we've been thinking about. Down here shows the percent breakdown. So here's the total number of entries removed on average. You can see 2019 had the lowest. Looks like it's getting worse. 2022 had 14% removed. That's the average. And then you can see from each step, we removed the division by 0. So if anybody reported 0 hours or 0 employees, we had to remove it. That was only 0.36%. For companies that reported less than 11 employees, less than 1,000 hours total for the year, or less than 100 hours per employee, 100 hours a year, that was a big portion. People were underreporting those things. So if you underreport the hours, what does that do to the incidence rate? Makes it go up. If you overreport, that makes it go down. That was a small percent, but ultimately we ended up removing almost 13% each year. That's too much. Too much garbage. Garbage in, garbage out. Here's our final comparison of rates. And there's a couple things we did. In order to remove the division by 0, I was able to calculate incidence rates individually like I did back in the data from the early 2000s. And so what I've got here are total case incidence rate and DART incidence rate. After removal of the highs, this is by overall, by entry, and then the median. I also calculated the median. And so we highlighted the overall. So overall are these here. Total case incidence rate, DART incidence rate. What's interesting is calculating by entry was higher, but had a similar trend, but it was higher. So when you calculate things by entry, what it does is it's a better representation and it's higher. So let's go. So when I did it by median, which is the 50th percentile, if you had a normal distribution, these would basically be the same, but are they? No, they're not. It's actually it's lower and it's a different trend. It goes down. So that's weird, right? The final one, I actually brought in the Bureau of Labor Statistics data. So this is the DART for the Bureau of Labor Statistics. It's not perfect, but it somewhat matches with our median, which is weird because it's different here. And then the TCIR up here also somewhat follows the median by entry. So the median calculations tended to be closer to the BLS, but not perfect at all. They deviated differently. Our calculated TCIR, DART, both overall and individually, were higher than the Bureau of Labor Statistics. So do we have more honest reporting, or is it after correction it's more accurate? And by the way, it's also going up. Oh man, I thought I was going to show you guys something else that I had done. Obviously, I didn't copy and paste it. Oh no, I did. I showed you that the numbers are different than what they're predicating everything on. So in conclusion, before any analysis perform, you have to do a descriptive table and look at the distribution. If you don't do that, then you really don't understand anything about normality, and you have no business doing statistical analysis. Now, why aren't people doing that? Because not everybody is classically trained as a statistician. I mean, my emphasis in my PhD was a distributed or a methods focus. So I spent a lot of time analyzing data and understanding it from different statistical methods. In fact, my statistical regression class, the first exam, I got 112% on it because I nailed all the extra credit too. What we need to do is really identify irregularities, oddities, outliers, and consider or remove them or isolate them and study them. I think that's a better way to approach SIFs versus just assuming everything the way it is. I don't like the assumptions. I agree. I obviously agreed with some of it, but not all of it. We also need to employ a more realistic understanding of injuries and how it's difficult, let's say impossible, to not record a fatality or a severe injury that's going to be there, whereas everything else has a possibility, as a variability that it may not have to be recorded. So therefore, it's not a great comparison. There's different influences there. So to compare the two, not a good thing to do. In addition to, I do think there is quite a bit of overlap to the causal agents and the precursors, but it's not 100%. And we kind of know what those things are, and so they should be identified and brought out. Here's my other contention, is that if traditional safety approaches were effective, why do we have things still going up or staying the same? We should be learning every year and correcting things, but obviously that is not the case. So we do need to change the way we do things. And I think it starts with better understanding or defining the problem. I really think that's where it is. So what does this all mean for you? As we continue on this journey of analyzing the loss run data, we're going to take our time, and we're going to really try to let the data tell its story, knowing what we know about it. And we're going to be cautious, and we're going to try to be optimistic that however we've managed the safety program up till now, this is the result. And that's a combination of things, you guys. It's both the work the safety people do, the safety committee, the supervisors, the training, the new workers, all that stuff, management's decisions. That's all what has resulted in this. Nobody wants anybody to get hurt. Workers don't want to get hurt. But in the course of doing work, harm was done. It's better to try to understand it that way, that if we can narrow the issues to particular tasks or particular causal or precursors, we now have the ability to study it deeper, understand it better. And I think that this effort on SIFs really moves in the opposite direction of that, though I see some common moving forward, but I'm afraid it distracts from it. So this week, we're going to look at outliers and see if they're unique. And then we're going to look and see how they affect our trending and forecasting overall. Next week will become even clearer because we'll be identifying priorities and narrowing to them. And I think that's really important. I think that's what we need to do with this data too. Looking at the full scope gives us a little bit of insight, but all I'm trying to look at are what are the issues? Where do things things look odd or erroneous? If we can kind of narrow things down to an industry or a state or something like that, we'll know a little bit more. But each individual company operates kind of on their own. When you look at them all combined as a collective, sure, there may be something interesting, but I don't know if that's the right way to look at this data. Based on what you've seen here in this video, Dr. Nakayama and I are going to write a paper on SIFs. And some of the work I just presented to you that I did with that grad student. And then I've got several new rounds of papers that are going to come out of that original analysis. So what I showed you is descriptive and somewhat qualitative in interpretation. I am going to do a deep dive statistically into determining normality levels of the data and how our 3 steps may have improved it. The next one will be to look at just private industry data by size of company, because I think size of company dictates resources and possibly communication. And we're going to analyze it through that. And then I want to do a comparison between certain industries, and a final one will be to compare certain states. I want to compare state-run OSHA programs against federal programs. So like Minnesota versus Wisconsin, maybe Illinois versus Indiana. I'm going to try to pair up like 6 different states that are either state-run. So it's kind of similar geographically, similar industry and size, and see if there's a difference in injury rates and death rates in states that are federal versus state. The hypothesis is that state should be safer and less fatalities because they customize some of their work. So I don't know what we're going to find, but so I've got a series of papers to write over the next year, and you guys got to see kind of the impetus for it or the beginning of it. All right. So watch the next 2 videos, work on the loss run data analysis.